students, welcome to statistics class. In yesterday's class we discussed about Poisson distribution. What do you mean by Poisson distribution and what are the different features of Poisson distribution. Now in today's class we will discuss two problems under Poisson distribution. See, these problems look similar with Poisson distribution and binomial distribution. These problems it looks similar. Once if you see both the problems, it looks similar, but there is difference. After completing Poisson distribution, I will differentiate between binomial and Poisson. Now here mainly you need to understand, in case of binomial distribution we have two parameters, that is m and p. Initially we need to find out what is m and what is p. But in case of Poisson distribution, there is only one parameter, that is lambda. In Poisson distribution problem, if we understand that it is a Poisson distribution problem, we need to identify a lambda. There we get only lambda value, but there won't be n or p. Sometimes you will get n and p, that is binomial kind of problem. If we are unable to solve, then we are solving under Poisson distribution. But in case of Poisson distribution problem, they will be having only one particular value, that is lambda. Usually when you read the problem, where in a problem if it's a mistakes or if it's a defects, such kind of problem you will get in case of Poisson distribution. And there you need to identify the value of lambda. Usually it will be the value with the word on an average. On an average, for example 1, 2. Such values on an average, the value along with the word on an average, it is most of the time it is lambda value. It is lambda value. So you need to identify the value of lambda first, and the lambda value, then we need to substitute into the formula. Now we'll see the problem here. The first problem we'll see there. As I said, here n won't be there. Here also problem like at the most, at least, or exactly 1, exactly 2, or more than 2. Here the difference between binomial and Poisson, in case of more than 2 or more than 2, then we get slight difference between binomial and Poisson, because in case of binomial, if it is more than 2, for example n is 3, and their question comes more than 2 means what we need to take? P2 plus P2. The same problem, if same question if we get more than 2, in case of Poisson, there n won't be there. What we need to take? More than we cannot take, but we need to take before that itself. So more than 2 means what we need to do in case of binomial? 1 minus P0 plus P1 plus P2. Then if P0, P1, P2 if we deduct from the total, then more than 2 will remain, or it may be what may be the n we don't know. Here we won't get n value. So any number more than 2 will remain there from the total if we deduct. This is in case of Poisson. This is in case of binomial. We can go above that number because we have their limitation, n is equal to 3. Here we cannot go above because we don't have n value. We don't know what is our limitation. We do not know here. So that is one difference between binomial and Poisson that we will see while solving the problem. Now we will see, read the problem here. A typist makes 2 mistakes per page on an average. Per page he makes 2 mistakes on an average. Find the probability that a page typed by him has 2 mistakes. That we can take directly P of 2. At the most 2 mistakes. At the most 2 mistakes means P0 plus P1 plus P2. At the most we can go up to 2, not more than that. From least to that number we need to go. P0, P1 plus P2. Now, how to start the problem? Solution. Write there lambda value you can write if you want. Lambda is equal to, what is the value of lambda? 2. On an average what mistakes? 2 mistakes. So that is the value of lambda. Here we require only we can write. Now next write the question x. What we are finding out here? The number of mistakes per page. Right there. Number of mistakes per page. Same like binomial. Then x equivalents b. There it was b since it was binomial. Here x equivalents p. It is Poisson. Which value we have to write? The parameter we have to show. What is the parameter? Lambda. That value is 2. Then we used to write parameter n and p. Here we need to write the lambda value. Then probability mass function. P of x is equal to here e to the power minus lambda to the power x divided by x factorial, and x is 0, 1, 2 till infinity. That is the range. Then according to this problem here e to the power, what is the value of lambda? Minus 2 and 2 to the power x divided by x factorial, and x is equal to 0, 1, 2 till infinity. Now take the first question, that is 2 mistakes. The first question is here P of 2 mistakes. 2 mistakes that we take as P of 2. P of 2. Now substitute into the formula e to the power minus lambda, that is 2. Lambda to the power. Lambda is 2. 2 to the power x. 2 to the power x. What is the value of x here? X is 2 divided by x factorial. X is 2. So 2 factorial. What is that 2 factorial? 2 factorial means 2 into 1. 3 factorial means 3 into 2 into 1. 4 factorial means 4 into 3 into 2 into 1. That is factorial. We need to multiply till 1. Now here you see e to the power minus 2. This particular value we have to get it from the statistical table. There in your textbook there is statistical table. In that page number 428. 428 there is one table, Poisson distribution exponents. In this particular table you have to take this e value. Where you need to see, here see lambda value start from 0.0, 0.1, 0.2, and here we have the lambda value as 2. Don't consider this minus. These values are given, that is minus 2, minus 3 values only they have given. So since our lambda value is 2, now where we have to see, here after 0.0, 0.1, then 0.9, after that 1 point, 2 point, 3 point numbers are there. Where we need to see, since it is 2, we have to see in the 2 point. Now we don't have 2.1, 2.2, we don't have. If it is 2.0, 2.1 means here 2, second row, first column. Then second row, second column, 2.2. But here it is only 2, where we need to see here second one, 2.0 column we need to see. 2.0 column, there lambda value is 0.1353. Here 2.0 column lambda value is 0.1353. See here Poisson exponents lambda value. Our value is 2, so we need to see 2.0. There if it is 2.1 means 2 and first column. There 0.1224 we get. Since here it is 2.0 we have to see, there we get 0.1353. That is the value of lambda. 0.1353. Then into 2 to the power 4. Sorry, 2 to the power 2 we get there 4 divided by 2 factorial, that is 2 into 1, that is 2. So here 2 ones are 2 2 2s are. What will remain there? 0.1353 into 2. Multiply there 0.1353 into 2. There we get 0.27. Right here again 0.2706. So this is the value of P of 2. Then we completed with the first question, P of 2 e to the power minus lambda. This particular value we need to get from the table. Then 2 to the power 2 divided by 2 factorial. Now we move towards the second question. There it is. At the most 2 mistakes. So P of at the most 2. There comes P of 0 plus P of 1 plus P of 2. If it is at the most 1, then P of 0 plus P of 1. If it is at the most 3, then P of 0 plus P of 1 and P of 2. Now we'll extend here. Now first one, P of 0. Take the equation. E to the power minus 2 to the power x, 2 to the power x, x value here it is 0 divided by x factorial, so 0 factorial plus second one e to the power minus 2 to the power, that is here also lambda comes, lambda to the power x, what is the x value here? 1 divided by 1 factorial plus e to the power minus lambda, e to the power minus 2 lambda value, and lambda to the power x, lambda is 2, power x here once again it is x value is 2 and 2 factorial. Now here e to the power minus 2 we have seen from the table, that is 0.1353 into 2 to the power 0. Anything power 0 is value is 1 into 1 divided by 0 factorial, their value is 1 plus e to the power 2, that is 0.1353 into 2, here 1 factorial 1 plus e to the power minus 2 once again 0.1353 into 2 to the power 2, it is 4 divided by 2 into 1, 2 factorial means 2 into 1 2. Here again 2 ones are 2 2s are. Now next comes here, what remains here? Here 0.1353 plus 0.1353 into 2, 0.2706, which we have already got, same calculation, plus here 0.1353 once again into 2, once again same thing we get 0.2706. Now add these three calculations. When we add 0.1353 plus 0.2706 plus 0.2706, then we get 0.6765. This is the second answer. With this, we end with the first example. There, firstly we need to identify the lambda value. Here lambda value we need to identify. If you want, here only you can get the table value. You can write this 0.1353. Then same like binomial distribution here. Then we are substituting the x value into the formula. X value into the formula, and this v value we get from the exponent table, Poisson distribution exponent table in the statistical table. Then the same calculation, what calculation required we need to do. Now we will move toward the second problem. Now we will see second problem. Read the problem there. On an average, a telephone operator receives 3 telephone calls. On an average, he receives 3 telephone calls per 5-minute interval. Find the probability in that 5-minute interval he does not receive any call. First question, he does not receive any call. Second question, he receives more than 3 calls. Now, see here, as I said, firstly you need to identify here lambda. You may get confused. Here you have two numbers, 3 and 5. But what is lambda? What sentence you have to observe? On an average, what is the number? So here, on an average, a telephone operator receives how many calls? 3 calls. So what is the lambda value? Lambda is equal to 3. So in this particular problem, the value of lambda is equal to 3. Solution, let the solution there. So value of lambda is equal to 3 here. Then what is that 5? That is 5 minutes. See, in case of Poisson distribution, they will give the number with very much specification they will give. In previous problem, if you see, per page means there also one number. Per means one page. For one page, what is the mistake? 2 mistakes. 2 mistakes per page. So they will give clearly the specification they will give. For one page, there is a 2 mistakes. Now here also this is the specification. 5 minutes interval, 3 calls. For 5 minutes, 3 calls. So that information they have given. So 5 is, that is the specification. In that 5 minutes, what is the number of phone calls? 3. So in that 5 case, find the probability. That 5 minutes he does not receive any call, means P of 0, none. He receives more than 3 calls. More than 3 calls means what may be the number? More than 3. We don't know the limitations. We don't know the n value. 5 is not a n value. That is a minute. That is a minute. Here we need to identify. We need to find out the number of calls. How many number of calls in that 5 minutes? Does not receive P of 0. We receives more than 3. What is the probability that we receive more than 3? More than 3 means any number. We don't know the value of n. Binomial means the n limitations will be there. 4 is a n value. More than 3 means what probability you can take? P of 3 plus P of 4. We cannot go more than that because they will give the range. N will be there. But in case of Poisson, n will not be there. So you cannot go with this possibility. Above that number, you cannot go. What you can do here? More than 3 means what you can do? More than 3 means you have one option. From the total, if you deduct none, P of 0, the possibility of does not receive any call, plus possibility of receiving one call, deduct. Possibility of receiving 2 call, you deduct. What is the question? More than 3. Possibility of getting 3 calls, you deduct. From the total, possibility of receiving no calls, possibility of receiving 1 call, possibility of receiving 2 calls, possibility of receiving 3 calls, you have to deduct. If you deduct that, what will remain? From the total, if you deduct that, then what possibility will remain? Possibility of receiving more than 3 calls. More than 3 calls, obviously it will remain. In case of Poisson, the difference between binomial and Poisson will come in case of receive more than 2. For example, if they given question as 2 or more. 2 or more means, 3 or more. They have given more than 3. 3 or more if they give, this 3 we should not include. Receive, the possibility of receiving 3 or more. So we need to deduct no calls, 1 call and first call, receiving 2 calls we can deduct. So there what will remain? Receiving 3 calls or more than 3. Here they have given more than 3. 3 also we need to include here, that we need to deduct from the total. From the total, if these possibilities if we deduct, then what will remain? More than 3 will remain. Now Now we'll solve the problem. Now here lambda is 3. Now x we need to write, that is number of calls per 5-minute intervals. Per 5-minute interval. 5-minute intervals, and x, then x equivalents p, that is a Poisson variate x with parameter lambda. Poisson variate x with parameter lambda is 3 here. Then probability mass function p of x is equal to e to the power minus lambda, lambda to the power x divided by x factorial, where x is equal to 0, 1, 2 till infinity. Then probability mass function according to this problem, p of x is equal to e to the power, what is the lambda value? Minus 3, and lambda to the power x divided by x factorial, and x is equal to 0, 1, 2 till infinity. Now take the first question. P of does not receive any call. P of does not receive any call. So here we need to take P of 0. Now substitute 0 into x. Here e to the power lambda is 3, lambda to the power x is 0 divided by x factorial, 0 factorial. Now this value we need to get from the table. What we need to see in the exponential table? 3. There we have to see 3 and which column? 0 column. 3 here, 3, 0 column, that is 0.0498. 3, 0 column. 0.0498. And 3 to the power 0 into 1 divided by 0 factorial is 1. So here what will remain? 0.0498. This answer only 0.0498 will remain. Come to second question. Here P of more than 3 calls. More than 3 calls. I hope it is clear what explanation I have given. If you are not clear, you have to verify. Means from 1 we have to deduct P of 0 plus P of 1 more than 3 calls. Right? More than 3 calls. Here what we need to write? Here 1 minus P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 3. Now take the formula. First one as it is we get this value e to the power minus 3 to the power x is 0 there divided by 0 factorial plus then e to the power minus 3 to the power x value is 1 divided by 1 factorial plus e to the power minus 3 to the power 2 and 2 factorial plus e to the power minus 3 and 3 to the power 3 divided by 3 factorial. Sorry, here we need to write. I'll take it here. Here it is 1 minus. It is 1 minus. Now next one. 1 0 means 1 and here also 1. So no need to take that. Here we will get 0.0498 plus e to the power minus 3, same thing, 0.0498 into 3 to the power 1, that is 3 divided by 1, no need to write there, plus this one 0.0498 into 3 to the power 2, that is 9, 3 to the power 2, that is 9, divided by 2 to the 2 factorial, there 2 will remain, plus last one e to the power minus 3, 0.0498 into 3 to the power 3, that is 27, and 3 factorial. 3 factorial means 3 into 2 into 1. So 6. Now solve this. We come here. 1 minus here 0.0498 plus 0. Next one, this one 0.0498 into 3. What do we get? 0.0498 into 3, 0.1494 plus next one 0.0498 into 9 divided by 2, there we get 0.2241 plus last one 0.0498 into 27 divided by 6, there also we get 0.2241. In these two also we get same value as answer. Now add this 1 minus these 4 values also we have to add. 0.0498 plus 0.1494 plus 0.2241 again 0.2241. There we get 0.6474. Then when we deduct 1 minus 0.6474, at last we get 0.3526. This is the answer. So this is the second problem. Here we end with the second problem. Here difference is in case of binomial and Poisson, if you get more than 2 or more than 3, more than or 2 or more, 3 or more, such kind of number if you get, in case of binomial 1 minus you have to do only in case of at least, but here you have to do at least as well as more than 2 and 2 or more, such kind of situation also you have to here deduct from 1. That is the difference between binomial and Poisson. I hope these two problems are clear. If you have any kind of queries, you can clarify. And with this, we will wind up with today's class. And in tomorrow's class, we will discuss 2 more problems under binomial distribution.